Hello, this is Ms. DB, and in this video we are going to review some of the important parts of Chapter 3, Section 6, which is on solving compound inequalities. Our objectives are to solve compound inequalities with one variable and to graph solution sets of these. So far what we've worked with was simple inequalities. Like if you have x plus 3 is less than 8, that's a simple inequality. There's only one inequality sign and one variable. When we combine two of these into one statement with the words and or, the result is called a compound inequality. So a compound inequality is when we have either an or like this, x is greater than or equal to 2, or x is less than -1. That's a compound inequality. We can also put that together with the word and. So here we have x is greater than -2 and x is less than 1. So x is both greater than -2 and less than 1. And we often will put that into one statement like this, where the x is in the middle. So let's look at this. If we have x is less than 1, that's what I said right here, x is less than 1. And I also said that x is greater than -2, but do you see how I flipped that around? X is greater than -2 is the same as -2 is less than x. If I have it this way, then I can take this and put it on the left side of my compound statement. So -2 is less than x, x is less than 1, so you can put it together in one statement like that. So here's an example. We have, it says to write a compound inequality for each statement. If there's an or, not there, and a number x is either less than -4, yeah, it's right there, or greater than or equal to 3. So this or here tells us that there's going to be an or in our compound inequality. The ors cannot be combined, so you just write x is less than -4, there's that part, and then the other one was x is greater than or equal to 3. Greater than or equal to 3 is written like that. So the ors will have two separate things. The next one says a number x is both. That's a clue that this is going to be an and. Greater than or equal to -7 and less than -2. So let's write both of those parts. X is greater than or equal to -7 and x is less than -2. So we wrote both parts separately, but these can be combined. If you rewrite the first one with the x on the right side, that would be the same as -7 is less than or equal to x. Once you have the x in the middle of both on either sides of the and, then you can combine this to be -7 is less than or equal to x and less than -2. So this would be our final answer as I wrote here. Now notice that both of those inequality signs are pointing the same way. That's how you have a good indication that you did this one correctly. We can graph these two and we'll look at that next. Okay, here's some examples from your worksheet. I'm just going to write this one the way we finished it up. So this would be -7 is less than or equal to x is less than or equal to -2. That's our and statement. Our ors will stay as two separate things. Okay, number one says a number x is either means or. So it's either less than -2 or greater than 4. So our first one is that x is less than -2. So you just write x is less than -2. Or you have to type the word or, x is greater than 4. Now it doesn't say x again here, but it means it. It means x is less than -2 or greater than 4. You have to write x on both of them. Now the next one's going to be an and I know that because it says both and because it has the word and here. So our first one is x is greater than 0. X is greater than 0. The second one is x is less than 10, and the word and goes between it. If it's an and, it can get written as one statement like we did up here. So flip this one around. That x is greater than 0 is the same as 0 is less than x. So now we can put this one and this one together. 0 is less than x, and x is less than 10. So here's our final answer for number 2. And you need to do the same thing for number 3 and number 4. One will be an or, and one will be an and. Number x is both greater than or equal to 5 and, oh, I cut off the rest, but you'll see it in your worksheet. Okay, here's about how we will graph this. So if we have all real numbers greater than 2 and less than 6, you can either have it as 2 separate statements or combined this way. What we do is we put an open circle at 2 and at 6 because neither of these have or equal to as part of the inequality. And then we want the numbers both greater than 2 and less than 6. So the and will be a combined overlapping region where just that is true. The numbers that are within here are both greater than 2 and less than 6. For example, 4 is greater than 2 and less than 6. Here's an example that included the or equal to. All real numbers greater than or equal to 2 and less than or equal to 6. So then we would use closed circles at those points. You can also do one can be open circle and one can be a closed circle. They don't both have to be the same. And we'll look at an example of that. If it's an or statement, you're going to have 2 different parts of your graph and they'll be pointing away from each other. So in this one we have all real numbers less than 2, so that's an open circle and an arrow this way, or x is greater than 6, so that's an open circle and pointing to the right. And then if they have lines under them, one or the other, you would use a solid dot instead. So one could have a solid dot and one could have an open circle too. And here's how it shows that you could do that in 2 separate graphs and then put them together. When you're putting the and type together, you only include the numbers where both lines overlap, where they're common solutions. All right, so let's look at these problems. The graphs are over on the right and the compound inequalities are on the left. So we're going to try to find the right graphs that go with the statements. Let's look at number 7. It says x is less than -6 or x is greater than -3. So we know that it's going to go 2 different directions. -6, so we should have a point at -6 and it should be an open circle. So it should be an open circle at -6. And then there also should be an open circle at -3 because it doesn't say greater than or equal to, it just says greater than. So find something that looks like this over here. Let's see. It looks like letter E would be the best match for that. So we would put E for 7. Let's look at one with an and, that's number 9 and 5 as well. -4 is less than x, or we could write that as x is greater than -4, and x is less than or equal to -1. So there should be an open circle at -4, sorry. -4 should have an open circle, and I want all of the values greater than that. We also need a closed circle at -1 because it says less than or equal to, and we want all the values less than that. So which graph would have the overlapping region from greater than -4 and less than and including -1? And that looks like B. So you could sketch it on your own paper and then find the matching one there. So here we have oval A represents some integer solutions of x is less than 10. So -1 is less than 10, -4 is less than 10, 1 is less than 10, 2 is less than 10, -7. All of the ones inside this this circle, this oval, are x is less than 10. And then in B, I'm going to use a different color here, we have in this oval, we have all of the values where x is greater than 0. So 1, 2, 7, 9 are all greater than 0, 12, 25, 15. Those are all greater than 0. The ones in this overlapping region, do I have a purple? I do. In this region, these are those that are both solutions to x is less than 10 and x is greater than 0. So these would work in either one of those. So that gives you an idea of how you can graph, because the place where they intersect, the solutions intersect, That's the solution. So that's how you can graph a and compound inequality. Think about where the solutions to both of them would be. So here's an example. We have -5 is less than x plus 1 is less than 2. Now this is not just x in the middle. We have to solve. X is not by itself yet. You cannot graph until x gets by itself. So here's how we solve it. There's two ways. The first way is to leave it written as it is and subtract 1 from all 3 sides of the inequality. It's not just 2 sides, it's actually 3 sides. So we'd subtract 1 from the left, 1 from the middle, and 1 from the right. And when you do that, you get -6 is less than x is less than 1. The other way, I'm going to do it over here, is to rewrite this compound inequality as its 2 parts. So this means that -5 is less than x plus 1 and x plus 1 is less than 2. So you rewrite it as its 2 parts, and then you solve each part. So this would be -6 is less than x, and we could change that to x is greater than -6. And subtract 1, x is less than 1. So we would need to graph x is greater than -6 and x is less than 1. That's what this says as well, but it's a little bit trickier to graph it when it's all in one part. So we're going to graph, the first part is -6 is less than x, which is the same as x is greater than -6. So let's put a -6 here. The next part is x is less than 1. So we graph that part. And then finally we would have to have where those intersect, the overlapping region where both of them occurred, which would be between -6 and 1. They both have open circles because they're both just less than signs. They're not less than or equal from the beginning. Okay, this is another one very similar. And I'm going to go ahead and write that as 2 separate inequalities. And then I will simplify each inequality. Make sure that you get this whole part when you write 8 is less than, it's not 8 is less than 3x, it's 8 is less than 3x minus 1, and then 3x minus 1 is less than or equal to 11. And then you solve each part. So this would be 9 is less than 3x, divide by 3, and we get 3 is less than x. That's the same as x is greater than 3. For our second one, we start by adding the 1 to both sides, and we get 3x is less than or equal to 12. Divide by 3. Make sure that if you ever divide or multiply by a negative number that you switch the inequality. Oh, and I switched it even though I was dividing by a positive, so I shouldn't have. X is less than or equal to 4. Okay, so now we're going to graph that, and I'm not going to do 2 separate graphs. I'm just going to do 1. Let's find 3. And we want x is greater than 3. So we'll put an open circle at 3, and our arrow will go to the right. We want all the numbers bigger than that. And then our next one is that x is less than or equal to 4. So we need 4 on our number line. We need a solid dot this time, and all the values less than that. So our actual graph would be all of the values between 3 and 4. You can include 4 because it has a solid dot, but not 3 because that's an open circle. And I'm just gonna, this is their graph, which will look like our graph when they get done. Except theirs is teeny tiny. Okay, here's some problems from your worksheet. So we're going to first rewrite these. So this means -3 is less than x minus 4. And x minus 4 is less than or equal to 10. So, and then solve each one and put the intersection, the overlapping part of the graph on here. In this one, we would have 8 is less than or equal to m plus 4, and m plus 4 is less than or equal to 15. Neither of these look too difficult to solve, but let's do number 11. So in 11, we would start by subtracting 4 from both sides of this inequality, and we would get 4 is less than or equal to m. That's the same as m is greater than or equal to 4. So we know we're going to have to put 4 somewhere on our graph, but I'll wait for a minute and see what happens on the other side. This means that I have to subtract 4 from both sides. So I have m is less than or equal to 15 minus 4. 15 minus 4 is 11. So I need 4 and I need 11. You don't have to have 4, 5, 6, 7, 8, 9, 10, 11, unless you want to. I mean, we have enough room. 5, 6, 7, 8, 9, 10. This would be 11 here. So I need a closed circle at 4 because it's greater than or equal. And then I would go this direction. And then at 11, I also need a closed circle because it's less than or equal, and I'm going to go this way. So I need I'm going to put a solid line between 4 and 11, and there would be solid dots at both. And now these are the or kind of problems. So if we have the x is less than 0, these are all examples of less than 0. Negative 78, negative 4, these are all less than 0. Greater than 10 are these values. There is none in common with each other, so there's no overlapping region. There's no numbers that are less than 0 and greater than 10 at the same time. So our graph is going to show that by going in 2 different directions. It'll show the less than 0 and it'll show the greater than 10. In this example, we have to solve these ones first. It's an or. They'll already be written as 2 separate inequalities, so you don't have to do that for your first step. So our first step is just to go ahead and solve each of those simple inequalities by subtracting 8 from both sides. And we get t is greater than or equal to -1 or t is less than -6. So we can graph them both separate if you want. There's t is greater than or equal to -1, solid dot, arrow to the right, and the graph of t is less than -6 looks like that. Open circle, arrow to the left. And then you have to have them on the same number line to have the solution. So you'll include both parts on the same number line. So you might as well just go ahead and do it on the same number line and save yourself a little space and time and effort. So in this one, we would divide 4x is less than or equal to 20. Divide both sides by 4. We're not dividing by a negative, so we don't have to worry about that. On this one, we're dividing both sides by 3, so we get x is greater than 7. So you can go ahead and find 5 on your number line. Here it would be. That's a solid dot, and we want all the numbers less than that, so that would go this way. X is greater than 7 would be an open circle, and we want all the numbers larger than that. So there's a few numbers in between that we would not be including in our graph. You can see. And that's what your graph would look like. So you solve each part, and then you put the graphs of each on the same number line. And here's the ones on your worksheet. And on your worksheet, again, they are already written or, so it's already 2 separate inequalities. So you just go ahead and solve each one. This would be b is greater than or equal to 7, or, and the or is part of your answer, b is less than or equal to -1. So I'm going to call this -1, and I need a solid dot because it's less than or equal. And in Word, remember, you can go to Insert Shapes and find the dot or a small circle, and then you can fill it in to shade it in, and you will find these rays in the same place, Insert Shapes. And then that would be 0, 1, 2, 3, 4, 5, 6, 7. But you don't have to, you can just put 7 wherever you want it to, and I'll believe that it's 7. And this would also be a solid dot in all of the values to the right. So every solution of a compound inequality involving and must work in both parts. If no numbers are solutions of both, then you say no solution. So it's usually the and ones that comes up, that there might be no solution. When you have the or, sometimes you have numbers that work everywhere. Like, here's an example. Like, let's say x is greater than or equal to 0, or x is less than or equal to 0. You didn't even have to solve this when it's just there. So here's my number line. Here's 0. I want all the numbers greater than or equal to 0, and I want all the numbers less than or equal to 0. Everything is a solution, so you would write all real numbers. That happens once in a while. And for the no solution, what if you had something like x is greater than 4 and x is greater than 4 and less than 3. So greater than 4 are these numbers, right? And less than 3 would be these numbers. There's nowhere that these two things are going to overlap with each other. There's no intersection. There's no number that's less than 3 and greater than 4. It's not possible. So you'd write no solution for something like that. So keep your eye out for that. That will happen once in a while. All right, that's it for today. Have a wonderful day.